We're wanted to talk about meeting measurement requirements with an integrated oil and gas solution today. So my name is Eric Syme. I'm a Director of Program Management at Prosoft Technology. And so we'll go over some how we meet those requirements with our in-chassis flow computer. And so first, just a little bit of history on Prosoft Technology. We've historically been known for a lot of our communication solutions, mainly our Modbus module. But today we're really focused on connecting disparate systems, our wireless connectivity, IIoT solution provider. And the thing we'll be talking about today is one of our application-specific solutions, mainly our flow computer. And additionally, we do a lot of stuff on modernization of older systems, bringing them up to newer systems. And we still do a lot of Modbus, but definitely a lot more than just Modbus in our portfolio here. We have products that fit directly into the Rockwall automation. We refer to those as our in-chassis solutions. They slide into the backplane. And we also have a full line of standalone gateway products, as well as industrial wireless and remote access products. And so specifically, what we're going to be talking about today is our Rockwall automation in-chassis flow computer, or in-chassis flow computer for both control and compact logic systems. So again, meet measurement requirements with an integrated oil and gas solution. And so really when we started looking at the market and what a lot of producers were doing out there, essentially we saw a couple different systems that were being put into place. A lot of producers were able to realize the benefits of a Rockwall automation platform, either control or compact logics, utilizing things such as like point IO for distributed IO. And so in this drawing, I just kind of show distributed IO is being used to take advantage of placing wiring directly next to separators and tank batteries at the wellhead itself. And then you've got your control system there. And this is a big benefit when you're commissioning and setting up the system. It allows you to reduce your overall cabling runs all the way back to a control room or to a control panel. And really at that point, you're just essentially providing an Ethernet and power right at the location that you need. But with each of those architectures, when we talk about measurement's a specific discipline that's required for either custody, transfer, or allocation measurement for oil and gas products. There's a very specific set of rules and standards that you have to follow with measurement. So at a lot of these oil and gas installations, you saw dedicated flow computers, and you have to network all of the flow computers together. You would as the oil and gas sites, these, in this case, a multi-well pad site, as it expanded the number of wells into a single pad site, it was beyond what could be done with a single flow computer. So you now have multiple flow computers running out into an area and had to network those all together. So created quite a bit of additional hardware on site, as well as a bunch more communication setup and networking of devices, because you had to share some of that measurement data with your process application. So that was a very standard installation that we saw in a lot of locations. Especially in North America, as some of the producers really started to streamline and reduce CapEx, starting around 2014, we saw where a lot of times although the benefits of the Rockwall architecture with distributed IO and a logics-based application were advantageous to automation groups, really producers had to look at ways to cut CapEx and really come up with a solution that reduce their overall CapEx. And so in a lot of instances, this was all being done with standalone flow computers, or RTUs, that were being used for both measurement and control. And while a lot of those systems are very good for measurement-related applications, as we started talking about control-based applications, there were some limitations that were encountered. And so with our traditional flow computers, a lot of times we're talking about devices from various vendors, from Emerson, ABB, TotalFlow, SCADA, PAC. And like I mentioned, it was typical to see either one device for measurement, another one for control or automation, or in some cases you were just using a measurement-based RTU and doing all your control and automation in that same system. The I/O counts on those platforms were typically limited, so they didn't scale to the operation. And so as producers started bringing more and more wells into a single well pad site, the I/O counts just didn't scale very well, and so they had to additionally add more and more RTUs. And as you added more hardware, you also had additional software and licensing costs for each of these different measurement-related functions. So not only was it not necessarily scaling to the size of the operations, but also created a lot more additional hardware and software and revision and control. So the benefit that you can get by utilizing a in-chassis flow computer is you essentially can bring that all into a single Rockwell-based control architecture. You've got a coprocessor module that essentially fits in the chassis with the controller and performs all of your flow calculations, gives you your measurement-related functions all within a standalone unit, and then additionally allows you to again take advantage of things such as distributed I/O around a well pad site or on a facility. So as we look at, and we mentioned oil and gas measurement requirements, some of those specific requirements are the allocation of custody transfer, allocation and custody transfer flow computing. You also have measurement-related functions to standards from industries such as API, AGA, GPA, and ISO. And so they basically create those standards, and those calculations need to be done by a dedicated, or by a flow computer. Data archiving is critical for measurement-related applications. The API minimum requirement is 35 days worth of hourly and daily records. And then additionally, you have to have a secure audit trail, an event log, and then the ability to lock out changes or keep track of all these changes. So as something like an orifice plate or gas analysis data is changed for a measurement operation, that has to be stored into the event log of a device, and it has to be recorded at what date and time that information was changed. Additionally, an interface to SCADA is a big requirement. So as we talk about SCADA operations for oil and gas, a lot of times you're talking about SCADA software such as Signet or AutoSol or various other interfaces. And so you need to be able to pass that, the historical data from a flow computer up into the SCADA environment. And then when we talk about measurement compliance standards, the main ones are usually like API 14.3, which is AGA 3, AGA 7, 8, and then API chapters 21.1 and 21.2, which calls out how the archive or historical data needs to be maintained in a flow computer. So all of these things are things that aren't native to the Rockwell architecture, but through the use of a flow computer coprocessor developed by Prosoft, we can go ahead and meet those standards. So when we look at some of the applications that this is relevant for and that we've had installations on, everything from LAC skids to pipeline monitoring, gas plants, multi-well pad facilities is all within the scope of this architecture right here. And I'll talk about a couple of the applications that we've done. So when we look at LAC systems in particular, which are lease automated custody transfer units, the Rockwell Compact Logic line is actually a really good line for this. It has a built-in power supply, some built-in I/O, and the amount of I/O requirements on a LAC skid is relatively small. But again, we get into where we need to have that flow computer capabilities that we can achieve through a coprocessor unit. A lot of times, also on a LAC skid, you're talking with multivariable devices or Coriolis meters that over a Modbus communication. So that's completely supported within this architecture. It allows a lower cost and basically the license-free model of the flow computer, as well as one of the key things when we started working with producers is measurement-related functions usually require, you don't necessarily want your measurement team requiring a license for Studio 5000 or RS Logix 5000 and become a PLC programmer to make changes. So we provide a free EAFC manager software that can be used to change things such as a meter factor of a Coriolis meter, or to go ahead and perform functions like transmitter calibration of a multivariable transmitter on your site. And for customers that are already familiar with the Rockwall architecture, it allows you to have less training, reduce your spare parts inventory, and really allows you to use Rockwall architecture in some measurement-related applications that you weren't able to do before. So one of our customers that implemented this solution was Pelican Gathering. They went ahead and utilized the Compact Logix control system, utilized Modbus communication to the instrumentation along with the flow computer. And additionally, they were able to take advantage of another product offering of ours, our cellular gateway and Prosoft Connect, to go ahead and connect to the site remotely over a cellular link. So really the problem they had was they wanted to combine measurement and automation in one solution. And from the remote connectivity standpoint, they really needed to reduce drive time to remote locations. A lot of the producers that we're working with, they're trying to reduce the amount of windshield time that their technicians are putting on vehicles. And so that helps them increase their efficiency and safety. And so remote connectivity is a great solution for that. And so they were able to use a Prosoft flow computer to get that measurement-related function into a site. When we talk about some of the multi-well pad sites, really, like I had mentioned before, the amount of the I/O that's being required at some of these larger sites is really exceeding the capability of what their traditional RTU or flow computer provides. And so in many instances, for something above like a 6-well or a 12-well pad, you're anywhere between between 3 to 5 or 7 different RTUs just to be able to handle the I/O as well as the measurement functions with a standalone flow computers. those multiple RTUs create all sorts of revision issues. As you update a program in one device, you then have to update it in multiple devices. Additionally, as far as commissioning, you've got a lot more time setting up your networking. And on these multi-well pad sites, one of the things that is different from some of the conventional measurement that was done back in the days is now we're looking at grid or generator power or large solar arrays on the site. So the RTUs were really good at low power installations, but on some of these larger well pad sites, power requirements are not as critical for low power devices. And so utilizing a Rockwall architecture on these sites gives you all the automation capabilities that you need. And also you've got high bandwidth communications, which can improve your data access and your efficiency. And so these larger well pad sites, the amount of information that they need to get from them as far as up to SCADA is increased as the well pad increases. And so you've got more and more tags that need to be collected from the devices. And so having that high bandwidth communication to those locations allows you to effectively utilize a Rockwall architecture. So again, when we were looking at some of those multi-well pad sites that were utilizing a Rockwall architecture, it was really utilizing Rockwall with standalone flow computers. Then you had things like either an RTU or a gateway that you were networking communications back and forth between those devices. And at the end of the day, all of that information has to go up to a SCADA host. So with an integrated flow and measurement solution, this combines everything into a single hardware platform based off the Rockwall architecture, and allows you to augment the Rockwall architecture with the measurement-related functions that are required on site. So one of our customers that has realized the benefits of this ARC resources, they have assets in Canada, and they're really more focused on results and creating value, their value creation at the site. And so their problem was their existing solution just really couldn't scale to the size of the well pad sites that they were anticipating to build. And so they really needed a scalable solution to reduce their CapEx. And so we worked together with the Rockwell and the distributor and Prosoft to present them with a solution that could scale to their needs. And what we came up with was a Rockwell Prosoft control architecture. And they were able to, with this architecture, their previous limit was 5 wells on a single system. And now that limit is up to 32. And the reason that they were able to realize that benefit is because the in-chassis flow computer is a co-processor unit. As they needed additional metering points on a well pad site, they were able to simply add another Prosoft AFC module into that chassis, and they were able to expand from the 16 measurement points that they were previously doing off one card to a total of 32 measurement points. And so as we've talked with producers, I mean, we've got producers that are building out well pad sites at 12 wells, 24, 36, and some of these well pad counts are getting as high as like 48 to 50 wells on an individual site. And so being able to take advantage of a scalable Rockwell architecture with a standalone flow computer or a in-chassis flow computer really gives you a lot of flexibility. And one of the key things for them was they were able to completely eliminate an additional control cabinet that housed their standalone flow computer. And so they're able to eliminate that into a single system. So when we look at a scalable Rockwell Prosoft measurement-related application, there's the higher the well count, the greater the cost savings. So as we look at 3, 6, 12 wells per pad, those savings just amplify the more wells that you're bringing into a single system. That's just in equipment alone. And when you start to factor in some of the additional savings that can be realized through spare parts reduction, engineering, cabling. I mean, I mentioned before the use of distributed I/O locally, right at your separators, at your wellheads, at your tank batteries, and to reduce home running cables all the way back to your control house, and really only having to run power and an Ethernet cable to those locations can really be beneficial in your commissioning time and reduction of cabling, and make it actually a system that's easier to troubleshoot as well. So with the scalable architecture of Rockwell, you can start out with something like the Compact Logix L24 or L27 for some of your smaller applications, skid-based LAC systems, or skid-based compressor applications, things like that, can all be done on a low-end Compact Logix. Whereas if your automation needs, the amount of memory, your I/O counts increase, you can then go ahead and jump up to something like the L30, L33, L36 Compact Logix processors, which gives you a lot more memory and I/O capabilities, and still have those measurement-related applications. And then, since all of these systems program with the Rockwell Studio 5000 environment, a lot of that code that you use or you develop can be reused as you move from one system to another one. And then we can also additionally scale up to the L8 or control logic systems. Again, you can take advantage of distributed I/O. And then one of the real benefits for producers is there's numerous options for communication networks. So the Rockwall architecture supports everything from HART, Modbus, Fieldbus, Profibus. So producers really can take advantage of best-in-class instrumentation and not be tied to a particular vendor, usually the same vendor that they're providing their flow computer.
Sorry to interrupt, Eric. We have a question here.
Yeah, I just see the question pop up, and the question was: Are we developing a flow computer for a 5380 Compact Logix system? And so the 5380 is the newest form of Compact Logix controller. Rockwell advertises it as their most powerful processor yet. And we are in communication with Rockwell, and we will be developing one of our first hardware platforms for that 5380 line, hopefully coming out early next year. And the flow computer is one of the things that is on our list that we are in discussions with Rockwell. So that being a very new platform for Rockwell, it took them a little while to open that up to partners such as Prosoft and other vendors. And so we are closely in touch with them, and we look to, in 2020, start releasing some products on that new platform right there. So good question, thank you. And so as one customer put it, and I stole his quote because I thought it was a really good one. He said that this is a cost-effective, industry-shifting, scalable marriage between automation and measurement. And so similar to one of the things that, I mean, if you remember years ago, the battle between IT and OT, and everybody was, the IT or the OT group didn't want to have IT involved on a lot of stuff, and you've seen a definite change in the last couple of years over there, where your OT guys are definitely, they have IT involved with everything that requires any networking. With certain organizations, we see a similar shift between measurement and automation. Before, there was definitely a divide where you had your measurement systems and your automation systems, and they were independent systems. Nowadays, everybody's trying to work together to come up with the best solution. And so by adding a flow computer to the Rockwall architecture, it really provides you the ability to create a best-in-class automation and measurement solution all combined into one. And the really nice part about it is, as your needs grow at a well pad site or through a facility, you can add just additional coprocessor units to get even more measurement points. So one of the things we see with a lot of producers is the measurement of water is almost as critical now as measurement of oil. So they're utilizing the same measurement techniques and archive capability on flow computers for measuring water. And so to be able to add just an additional card in there to add more measurement points as a facility grows or more wells come into a single site, it provides a ton of benefit there. The other thing that we've really tried to do is reduce licensing fees. Some other flow computers out there, you have to have one license for gas, another one for liquids. You can only license so many gas or liquid runs on a single device. With the Prosoft flow computer, we've eliminated licensing. So since it's a coprocessor, it fits in the rack. It's fully licensed as you receive it out of the box. And then for our measurement-related functions, we've got our AFC Manager software. So really, the benefits of a Rockwell Prosoft for an automation and measurement solution really allows you to engineer something once, scale it to what you need at your individual location, and reuse a lot of that code that you've developed. So when we look at the product lines, we've got a ControlLogix and a CompactLogix system. Our CompactLogix module supports up to 12 individual measurement points, whereas our ControlLogix module can support up to 16 on an individual module. And so that's really any combination of gas or liquid. So if you needed, we'll say for instance on ControlLogix, you've got 16 modules or 16 measurement points or meter runs. You can do 14 liquid, 2 gas, 8 liquid, 8 gas. There's any combination that you pick and choose just through the configuration of the software. And there's no licensing for any of the liquid meter runs. So gone are the days of having to transfer licenses over from over to a flow computer. So that was one of the benefits of this system right here. And then there was a question that just came in about a light unit that will only have 4 meter runs. We are still looking at coming up with a smaller version, potentially for our CompactLogix unit, but right now since we just released the main unit, the full featured one, I do not have anything in the works for say a light version right now. So good question there. When we talk about calculation methods, it's a lot of the standard AGA 3, 7, and 8 APIs, chapter 11 and 12. And then for flow measurement applications, really it's the requirement for data archiving is critical. And so this is what we're able to accomplish by utilizing a standalone flow computer. These archive records are stored in non-volatile memory. And once an archive record is stored or cut, that the record is in secure non-volatile memory. It can't be changed or altered in any way. And so that's one of the main reasons that some customers were doing this all in standalone flow computers was just the archiving capability. And when you talk about API requirements, I mentioned earlier that you had to support a minimum of 35 days worth of hourly and daily records. And we support up to 1,440 hourly records, which is 60 days, as well as the same 1,440 daily records, which is just under 4 years worth of archive capability right there. And then again, when we talk about configuration and monitoring software, as we worked with individual producers, it became very apparent that producers didn't want all their instrumentation and measurement guys having to become PLC experts and going in Studio 5000 to make changes. And so we created a standalone configuration software, can connect via Ethernet or serial port on the module. And it allows your measurement and your instrumentation group to do the specific functions related to measurement without having to go online with Studio 5000. So everything from meter configuration to site configuration to just monitoring the data, looking at what your flow rates are, what your accumulators are, going in and looking at the archive data. And then a key thing that we added about a year ago, year and a half, was the ability to do transmitter verification and calibration. And so as you've got a well pad site with multivariable transmitters out there, being able to calibrate those devices and do verifications on those devices as required through a custody transfer agreement was critical. So we were able to build that into our EAFC manager software so that you could calibrate and verify those devices. And then additionally for measurement related data, a lot of times there's third-party systems such as FlowCal that are used to basically validate and audit the data. And so being able to generate FlowCal CFX file format was another function that was needed. And so we went ahead and placed that into the EAFC manager software. So users could go ahead and generate CFX files or just CSV data and log a bunch of information that way. And one thing when we talk about standalone flow computers, many of those were interfaced through Modbus TCPIP. And so we've provided a similar Modbus TCPIP interface directly on our EAFC module. We can support up to 8 connections with devices, so anything from SCADA to configuration software to potentially even a operator station. This allows you to do remote diagnostics, configuration, and monitoring all over Ethernet connection. But then we also built in the support for Enron Modbus, which allows you to transfer alarm and event data and archive data with third-party systems, like I mentioned, such as Signet and AutoSol that are used for oil and gas measurement operations there. And so lastly, I mean, basically some of the, as we look at the top 5 reasons to consider or use an in-chassis flow computer, The main ones that I wanted to touch on and leave you with is the license-free model. Not having to license additional meter runs can basically ease field operations. Additionally, you can do more liquid measurement points, and creates a better way. And as someone's troubleshooting a system, they don't have to transfer licenses at 2 o'clock in the morning as they're trying to get something up and running and worry about licensing. It's all based on hardware that fits directly into the Rockwall architecture. By utilizing a modern PAC architecture, that can be scaled to what a producer needs. So they can oftentimes start off with some small skid-based equipment on compact logic systems, and as the needs of their well pad site or their operations grows, they can go ahead and scale that to larger compact logic systems or even eventually control logics. And because of the use of a single programming environment, the Studio 5000, it allows them to engineer once and reuse that. They can build add-on instructions in the system and reuse those on other areas. You can also add additional metering points. So say, for instance, you had a well pad site like Arc Resources, realized they ran out of number of metering points that they could do on a single module. And so it really was as easy as adding a second module into the system to expand from 16 to 32. And so being able to just add additional coprocessors in a chassis as your automation and measurement needs start changing at a site, you add additional I/O, you add additional AFC modules, and you get additional metering points there. The EAFC Manager configuration software provides a free user interface for measurement to be able to perform the functions that they need. So everything from changing out an orifice plate to entering gas analysis data to entering a new meter factor for a Coriolis meter. That can all be performed through EAFC Manager software, and so users don't have to utilize Studio 5000 and become PLC experts to do that. The ability to use distributed I/O allows you to really take advantage of things such as pre-wired control cabinets that sit out near the separators and the tank batteries. Minimizes your overall wiring on site because you're not home running 16 pair wire that's going all the way back to the control cabinet. Instead, you're just running a power and Ethernet, and you're going ahead and wiring directly to things like distributed I/O blocks on point I/O out on site. And then really you get to decrease your CapEx on installations. And so the greater the measurement count, the more savings. And again, if you need more metering points, you can just add an additional flow computer module. We've got architectures that are designed up to 5 individual modules in a system or 80 metering points. And there's still room to grow even beyond that. And really on commissioning and startup of these systems, you spend less time networking disparate systems together. It's all based in one Rockwell-based architecture, and you reduce your overall commissioning time. So I hope that was a good overview of the product offering. If there are any questions, we got a couple questions during the session, but if there's any questions now, we got some time to answer.
We got one here on the chat. Eric, do you have reporting capability from EAFC software or local from the device? Daily, monthly, configurable?
Yes, through the EAFC module or EAFC Manager software, you can go ahead and pull your archive data And so you can get the daily and hourly archive data. In addition to that, those daily and hourly archive records could also be used in a batch type operation. And so it basically would could be used on like a truck terminal application where every batch is its own record, and those batches get cut through the PLC interface, and users can go ahead and pull that information through the EAFC manager software, or again, they can use the export utility to export that information as .cfx file or .csv.